Europa is the most likely place to find life in our solar system today because we think there's a liquid water ocean beneath its surface. Now we know that on Earth, everywhere that there's water, we find life. So could Europa have the ingredients to support life?
We might be actually looking at a body that is presently alive, presently active, and presently undergoing its geology. There is too much evidence right now lying around on the surface, the red stuff, that suggests that something's going on there. Is that an environment that is habitable for any sort of life form? By golly, we really have got to go back and figure that out.
We have designed the Europa mission to take a spacecraft and its set of instruments all the way from planet Earth to Jupiter.
Previous mission concepts were for a spacecraft that would orbit Europa, but Europa is bathed in radiation from Jupiter. Any mission that goes in the vicinity of Europa is cooked pretty quickly. Instead, we're looking at a mission that will orbit Jupiter, make close flybys of Europa, and then zip out of the high radiation region.
Kind of like when I was a kid, we had the sprinklers, and we didn't want to be too close to the sprinkler head, so we would run in and get a little water and then run back out again.
This allows us to have a mission that's many years long and to collect and transmit lots and lots of data. As Europa orbits Jupiter, it flexes, and we could measure the gravitational change of Europa by encountering Europa at different points in its orbit. On a typical flyby, we would turn on our remote sensing instruments, we would image the surface, we would interrogate the surface with spectroscopy, and we would do the same thing on the way out. And we would essentially rinse and repeat and do this many, many times until we understand Europa globally. Images from the Hubble Space Telescope tells us that Europa might be erupting plumes of water high into space. If that's true, then we could fly through those plumes with a spacecraft and literally taste it to understand the composition of Europa's interior.
If it does have the ability to harbor life, how does that work exactly? We'll have enough instrumentation to really pinpoint exactly how the mechanisms would work for replenishing the nutrients in a subsurface ocean.
Europa is so important because we want to understand, are we alone in the cosmos? If there's life in Europa, it almost certainly was completely independent from the origin of life on Earth. That would mean the origin of life must be pretty easy throughout the galaxy and beyond. We didn't know till today that there's evidence from years ago that there's something there. Europa is one of the most fascinating bodies in the solar system. We think beneath its icy surface is a global ocean, twice the volume of all of Earth's oceans combined. In the late 1990s, the Galileo spacecraft explored the Jupiter system. It made about a dozen flybys of Europa. It took observations from its cameras and from its magnetometer.
By discovering that there was an induced magnetic field at Europa, we were led to the conclusion that there must be an ocean just beneath the icy surface of the moon. But there were some strange signatures in the magnetic field that we had never really been able to account for.
Images of Europa from the Hubble Space Telescope have hinted at gases that might have come from plumes erupting at Europa.
The Hubble images had given an estimate of the height and width, and I knew how fast Galileo was moving relative to Europa.
There are better tools now, better computational techniques, better computing, that we can go back and look at that old data set anew.
So my colleague Shinja Jha set up a calculation to see what would happen in the environment of Europa if there were such a plume. And when he ran this simulation, it agreed just beautifully with the data that we had collected.
reanalysis of the Galileo magnetometer data suggests that the Galileo spacecraft, on its closest flyby of Europa, flew through a plume. The Europa Clipper mission is going to explore Europa to investigate its habitability. If we find active plumes, then we can sail on through them and sniff and taste that stuff that's in the plume. We can analyze the particles and the gases to get at the detailed composition of Europa's interior.
The search for life beyond Earth begins with understanding life on our home planet. And that story, the story of life on Earth, may have begun in our oceans. And that's because, of course, if we've learned anything about life on Earth, it's that where you find the liquid water, you generally find life. So what if I told you that there is an ocean out there beyond Earth? An ocean in our solar system that has been in existence for billions of years. It's an ocean that is perhaps 10 times as deep as Earth's ocean. It's an ocean that is global and may contain 2 to 3 times the volume of all the liquid water on Earth. It's an ocean that exists beneath the icy shell of Jupiter's moon, Europa. So how do we think we know that Europa's ocean exists? Well, it's a combination of using telescopes on the ground and having spacecraft that have flown by Europa and collected data about the surface, about the interior structure, and about the magnetic field around Europa. And the combination of those data sets leads us to a high degree of confidence that this global liquid water H2O ocean is there today, and it's been there for much of the history of the solar system. We used to think that in order for a world to be habitable, you had to be at just the right distance from the sun or whatever your star was, such that you could have a liquid water ocean on the surface. Now, along with liquid water, life as we know it needs 2 other keystones. The first is the building blocks for life, the stuff you find in rocks. And the second is some form of energy to help power life. And here's where Europa is a real game changer. It is far, far out from the sun, and yet it's got this liquid water ocean. And the reason that Europa has liquid water is because it's orbiting Jupiter, and the tidal tug and pull causes Europa to flex up and down, and all that tidal energy turns into mechanical energy, which turns into friction and heat that helps maintain this liquid water ocean beneath an icy shell. Along with helping maintain liquid water, we think that tidal energy may also allow that ocean to interact with rocks on Europa's seafloor. And it may even give rise to things like hydrothermal vents, which could help provide not just the building blocks for life, but also the energy for life. The question of whether or not life exists beyond Earth, the question of whether or not biology works beyond our home planet, is one of humanity's oldest and yet unanswered questions. And for the first time in the history of humanity, we have the tools and technology and capability to potentially answer this question. And we know where to go to find it. Jupiter's ocean world, Europa.